Hello everyone, welcome back to my YouTube channel Trouble Free. In today's video, I am going to explain you about canonical form or normal form. So along with the basic introduction, I'll also explain you the one example problem. The other problem I'll be explaining in another video. Okay, so basically, what do you mean by canonical form or normal form is nothing but you will first of all you will use it to find out the rank of a matrix. You can apply both row and column transformations. In case of echelon form, we should apply only row transformations, right? But in case of this canonical form, you can apply both row and column transformations. Basically, whatever matrix you are having, you need to convert into an identity matrix. Okay, so when you convert it into an identity matrix, you will get this form IR000. So what is this? I will explain you. Here R is nothing but the rank of the matrix. For example, see here we have a matrix like this. Okay, suppose we have some matrix like 1 0 0 1 0 0 0 0 0. This is the matrix which we want. We have to get a matrix in this way. See, IR, this is IR, okay, identity matrix, okay, and others should be zeros. Identity matrix and others should be zeros. Its boundary elements should be zeros. Okay, starting from the first element, you need to get an identity matrix. It can be a 2 by 2 matrix, it can be a 3 by 3, 4 by 4, whatever it is. Okay, so if you are getting like that, then your problem is said to be completed, and whichever matrix, whichever identity matrix order you are getting it, that is the rank. Here what is the order of this identity matrix? It is 2, right? So the rank is equal to 2. Suppose you will get like this also. Okay, so this is the identity matrix of order 3. Okay, if you can observe, see, this is the identity matrix, okay, and the other boundary elements are zeros. You should get in that way. Got it? Or you can get a complete identity matrix, like here also 1 you can get. So if it is here also 1, then the order is 4. Obviously rank also will be 4. Okay, got it? So this is how you will be doing the canonical form. So I'll explain you 2 examples. Don't worry, with that you will understand it in a more better way. So let's get started. In this video I'll explain you one example. In the next video I'll explain you the other example, because otherwise the video will become very long. Okay, so reduce the matrix into normal form and find the rank. In the exam, if he is giving you particularly normal form or echelon form, you should use that only. If he is not giving you any particular thing, then you can go according to your wish. Got it? Now, so first observe the first row, first element. What it is? 0. So basically here you can do both row and column transformations, right? So in order to do any row transformations or column transformations, the first row, first element should be 1. Then only it will be easier for you to do the transformations, right? If it is 0, you cannot do anything. If you add, you will get the same number again. If you subtract, you get the same number again. You multiply, you get the same number again. So you cannot do anything with 0. So first what we will do is we will try to bring 1 over here. So how to bring 1? You can either do row or column operations, right? Since it is a normal form, it is not echelon form. So let us do the column operation so that we can directly get 1. If we are using row operations now, you have to get 4 or 2. Again you should do division by 4, so it becomes very big. So let us do with this column transformation. So that is nothing but, let us interchange C1 and C2. C1 is this and C2 is this. This is R1, R2, R3, C3, C4. Okay, columns, rows. Now let us interchange C1 and C2. Then what do you get? You get 1 0 1 0 4 2 2 2 3 minus 2 6 1. Okay, so this is what you get on interchanging C1 and C2. So once C1 and C2 are interchanged, done. So what is your ultimate goal in this normal form? You should get an identity matrix followed by zeros, right? So the first element is 1. Fine. this is, so let us do it column wise. Let us first make column 1 element 0, next column 2 element 0, column 3 element 0, like that. Let us go by column wise. Okay, so first element is okay 1, second element is 0, this is also okay, but here we have 1 again. It has to be 1, it has to be 0, right, according to our canonical form. So according to canonical form, it is supposed to be in this way. So this also should become 0. In order to make it 0, what can we do? 1 minus 1, you get 0, right? So let us do the operation like R3 minus R1. R3 tends to R3 minus R1. So what do you get? R1, R2 same. 1, 0, 2, minus 2, 0, 4, 2, 6. This is 4. Next. 1 minus 1, 0. 2 minus 0, 2. 3 minus 2, 1. 1 minus of minus 2, 3. Right? So now what we will do is 2, 1, 3. Yeah, correct. Okay, I'm just checking it. Next step, what you will do? Let me zoom in. Otherwise, yes, this is the maximum. Okay, fine. So now what we will do? We made this one and this one as zeros, right? Now what you can observe here is this is 2, 1, 3, right? This is 4, 2, 6. 2 2s are 4, 1 2s are 2, 3 2s are 6, right? So if you divide this R2 with 2, then you can make these two elements, these two rows equal, right? So you can also do this into 2, but let us do R2 divided by 2, then these two rows will become same. So now what is our operation? R2 by 2. R2 tends to R2 by 2. So you get 1, 0, 2, minus 2. Next, 0 by 2 is 0, 4 by 2 is 2, 2 by 2 1, 6 by 2 is 3. 0, 2, 1, 3. Done. Next, what we have to do? In this second column, which element is supposed to become 0? So actually, if you are considering it as a 2 by 2 identity matrix, this one will be 1 and this one also should be 1, but this thing has to be 0, right? First let us concentrate on making the elements as 0, right? See, because if you are making it as 0, obviously this all will become 0, right? So now what is the operation that we can apply? R3 tends to R3 minus R2, right? So if you do that, what you will get? 1, 0, 2, minus 2 as it is. Next, 0, 2, 1, 3 as it is, because you're not making any changes to R2 also. R3. So 0 minus 0 is 0, 2 minus 2 0, 1 minus 1 0, 3 minus 3 0. Done. So we got R3 as complete zeros. Now what are the other elements that you're supposed to make 0? So R3 is complete zeros, so obviously you understood that you will be getting a 2 by 2 matrix. So this will become an identity matrix, right? So now we have to make this one as 0, 0, 0, 0. So how to make those things as 0? Let us see now. So how to make this one as 0? You cannot apply row transformations here. Why? Because if you apply any row transformation, then the value of this 1 and 0 will change, right? So now let us apply column transformation. Even if you apply column transformation also, these values should not change. These values will obviously not change, because here you have 0 and 0, right? Okay, if I tell like this, you'll not understand. Let me do it. So let us make the operation like C3 tends to C3 minus 2C1. Why? Because C3 is 2 minus 2 into 1, which is 2 minus 2, 0. So you will get here 0, right? So C3 tends to C3 minus 2C1 and C4. C4 is also same, but here instead of 2 you have minus 2. So instead of minus you get plus there. That's all. C4 plus 2C1. So now let us apply the transformation and see what we get. So if you apply that, you get this will be same 1 0 0 0 2 0. Next, C3 minus 2C1. 2 minus 2 into 1. 2 minus 2, 0. Next, 1 minus, see, 1 minus 2 into 0. 1 only you will get, right? Next, this one also 0 minus anything, whatever you do with 0, you get 0 only. Now, C4. C4 is minus 2. See, C4 is minus 2 plus 2 into 1. Minus 2 plus 2, 0 you will get 0. Next 3 minus whatever you do with 0, you get 0 3 only, and again here also 0, here also 0. Any operation you will get 0 only. Okay, done. Sorry if you're not able to see it properly. Okay, now what we have to do, this is the identity matrix. We need to make this one and this one as zeros, right? And also along with that, this 2 also should become 1, right? So what we will do here is C2 will become C2 by 2, C4 will become C4 by 3. Let us do. So what you will get, 1 0 0 as it is. Next 0, 0 by 2 is 0 only, 2 by 2 is 1, 0 by 2 is again 0 only. Next C3 we are not doing any changes, 0 1 0. Next 0 by 3 is 0, 3 by 3 is 1, and 0 by 3 is again 0. Okay, so now again this is the identity matrix required, this and this has to become 0. Simple again. What you can do, C3 tends to C3 minus C2, C4 will become C4 minus C2. 1 minus 1 you will get 0, right? Here instead of C2, why can't we take C3? You will get it out. If you take C3 here, the value of C3 will become 0, right? So if you do here, you will get no use. That is why you have to take C2 only. That is the value which is not changing, you have to take. Here the C3 is changing, so you cannot consider that. So 1 0 0 0 1 0. Okay, next C3 will become C3 minus C2. So 0 minus 0 0, 1 minus 1 0, 0 minus 0 0 again. Next to C4 minus C2, 0 minus 0, 1 minus 1, 0 minus 0. Okay na? So we are done with the problem now. Why? Because you got an identity matrix surrounded by 0, which is nothing but I2 with surrounded by zeros, right? So you got a identity matrix of order 2. So that is why the rank of this matrix will be equal to 2. Okay, so the rank of this matrix will be equal to 2. If you want to check it, you can check it with the echelon form also, but I don't think so, nobody will do that. Okay, but still if you are interested to practice, you can practice the echelon form with this problem and check whether you're getting 2 or not. Okay, so this is all about this video. I know the video has become a bit long since this is the first problem related to the canonical form or normal form. It is long, so from the next problems onwards we will try to make it off shorter. We'll try to finish it off in a simple way. Okay, but still if I make it fast, you will not able to understand. So that is why I'm explaining everything step by step. So this is all about this video. Thanks for watching the video till the end. If you're still having any doubts, let me know in the comment section. Thanks for watching the video till the end.